This is a current, best-in-class Class D amplifier capable of reproducing 50 watt peaks per channel. Class D amplifiers are commonly thought to be about 90% efficient. Let's test that. The amplifier is connected to two regular 8-ohm speakers, and we use an MP3 player as the audio source. We are measuring average power consumption and we have a sound pressure meter to measure the sound levels. If we turn the power on, we see that the Class D amplifier has a quiescent power consumption of around 500 milliwatts. If we turn the volume to a typical background level, around 65 dBc, the power consumption hardly changes. If we turn it up to around 73 dBc, a level our customers define as near loud, the power consumption only rises to around 530 milliwatts. At normal listening levels, the majority of the power consumed is wasted in the amplifier rather than delivered to the load. In fact, a Class D amplifier is only at its most efficient when operating at maximum output power. The audium amplifier is a full bandwidth stereo amplifier rated to reproduce up to 50 watt peaks per channel. It's a completely digital design that accepts a digital audio input and integrates the amplifier control and switching power output stage. The entire amplifier is powered from a 1.5 volt rail. The device therefore includes power supply management, and as you can see, no heat sinking is required. So, let's do the same test as before. If we turn the amplifier on, we see the quiescent power consumption is about 6 milliwatts. If we turn our music to a background listening level around 65 dBc, as before, we are only consuming around 20 milliwatts compared to the 500 milliwatts for the Class D amplifier. It's perhaps surprising how much noise one can make with just 20 milliwatts of power. Let's turn it up. Even at our loud level, the audio solution is much more efficient than the Class D. And, under normal listening conditions, over 20 times more efficient. So, how does it work? Consider a sine wave. It has a peak to average ratio of 0.7. And since power is proportional to the square of voltage, this corresponds to a peak to average power ratio of 2, or 3 dB. In contrast, an audio signal has a much higher peak to average power ratio, usually around 15 dB, a ratio of 32 to 1. This high peak to average power ratio means that even when operating at maximum volume, the average output power of an audio amplifier is typically only a tiny fraction of its peak output power capability. This characteristic, coupled with the fact that you don't normally play your music at full volume, means the average output power is actually very low. Audium's technology exploits these facts to operate efficiently at all output power levels and still reproduce the peaks present in an audio signal. Imagine the USB port on your laptop can now drive these loudspeakers at up to 25 watts peak per channel without any other power source. The battery lifetime of a portable MP3 player speaker docking station could be doubled or trebled. Or, with just 4 standard C batteries, these wireless speakers could play for 3 hours a day at normal listening levels for 10 months.